हमारे आज के टॉपिक में पीडीएफ की कुछ प्रॉब्लम्स शामिल हैं। फाइंड द वैल्यू k so that the function fx defined as follows may be a density function f of x equal k of x, f of x equal kx, where 0 less than equal x less than equal to f of x equals 0 elsewhere from 0 less than x less than 2. Find the probability that both sample values will exceed 1. Compute the distribution function f of x. First of all, part A, the function f of x will be density function if this f of x is greater than equal to 0 for all value of x and integral from minus infinity to infinity f of x dx equal 1. यानी डेंसिटी फंक्शन होने के लिए इन दो प्रॉपर्टीज का पूरा होना अजहद जरूरी। इन दो कंडीशंस में से पहली कंडीशन सेटिस्फाइड होगी जब भी हम k ग्रेटर देन इक्वल 0 लिखें। अगर ये k पॉजिटिव होगा ग्रेटर देन इक्वल 0 होगा तो हमारी कंडीशन 1 ऑटोमेटिकली सेटिस्फाई हो जाएगी। द कंडीशन 2 will be satisfied if minus infinity to infinity integral from minus infinity to infinity f of x dx equal 1. That is, if 1 equal minus infinity integral from minus infinity 0 f of x dx plus integral from 0 to f of x dx plus integral from 2 to infinity f of x dx. That is, there 0, there also 0, and only interval from 0 to 2 interval is kx. 1 equal integration x square by 2, put 2, then we will get 2k, and this will give the value of k is 1. It means that density function f of x equal x by 2 for 0 less than equal x less than 2 and 0 elsewhere. Now check its area. Now we will find its area of a shaded region integral from 1. There will be answer 3 by 4. Probability of two sample values exceeding 1. 3 by 4. 3 by 4, that is 9 by 16. Compute distribution function of capital F of x probability x less than x. Integral from x of x for any x such that minus infinity less than x less than 0, hence distribution function equal integral from infinity to x 0 dx, with that will give 0. For 0 less than x less than equal to, we have the distribution function f of x, which will give the answer x squared. And finally, x greater than 2, distribution function will give the answer 1. Hence, distribution function is 0 when x less than 0. Distribution function is x squared by x from greater than 0 to 2. And distribution function is 1 for x greater than. Now, next example. A random variable x is continuous type with PDF probability density function f of x equal to x from interval 0 to 1 and probability density function as value 0 other than that from 0. Find probability of x 1 by 2, probability of x less than 1 less than equal 1 by 2, probability of x greater than 1 by 4, probability of x from the interval 1 by 2 to 1 by 2, and probability of x less than equal 1 by 2 such that 1 by 3 less than x less than 2 by 3. Clearly, f of x 0 and integral from infinity to infinity f of x dx is 1. यानी पीडीएफ की दोनों शराय पूरी. Since fx is a continuous probability function, therefore probability of x equal 1 by 2 is 0 and less than 1 by 2 minus infinity to 0 से 1 by 2. तो हम जब ये इसमें वैल्यूज पुट की तो आपसे 1 by 4, the probability of x greater than 1 by 2, integral from 1 by 2 to 1 to infinity, and answer 15 by 16. Probability of x from 1 by 4 less than x less than 1 by 2, integral 1 by 4 to 1 by 2, and its answer is 3 by 16. कंडीशनल प्रोबेबिलिटी का फार्मूला लगाइए तो पास जो पांचवा पार्ट उसकी वैल्यू 5 बाय आता है. हमारे पास जो नेक्स्ट एग्जांपल है, कंटीन्यूअस रैंडम वेरिएबल x हैज डेंसिटी फंक्शन f of x as follows. Find the probability density function. ये एक और एग्जांपल है, एक नजर देखते हैं इसको. Distribution function f of x has value 0 for x less than 0, x square by 5 for the interval 0 to 1, minus 3 by 5 plus 2 by 5, और ये इंटरवल 1 से 2 के लिए, और डिस्ट्रीब्यूशन फंक्शन 1 फॉर x ग्रेटर देन. हमने प्रोबेबिलिटी डेंसिटी फंक्शन का प्रोबेबिलिटी x mod less than 1 by 5 ये हमने बात. बाय डेफिनेशन ये डिस्ट्रीब्यूशन फंक्शन का डेरिवेटिव ले पीडीएफ डेरिवेटिव जब लिया गया ये बने सेंटर पूरे फंक्शन का डेरिवेटिव. probability x mod less than 1 by 5 करने को इंटरवल ऐसे बने, इसकी वैल्यू इसके लिए पुट करके वैल्यू हासिल करेंगे तो अंतर 0.7